So we've talked about the skills that are involved when working with concurrent lines. So that is 3 or more lines that intersect at the same point and proving that they do. Proving that these 3 lines intersect at that one point. What I'm going to do in this video, I'm going to set you a couple of questions on this. I want you to pause the video, have a crack at them, then come back and check your solutions against the working presented here. Here you go. So I want you to determine if those 2 groups of lines are concurrent. So the first one has 3y plus x is 7, y minus x is 1, and y minus 3x equals negative 1. And the second group is 4y plus 3x is 1, 3y minus 2x is 5, and 5y minus 10x is negative 5. So pause the video and have a ping. So the first set, so these were the 3 equations I had initially. So 3y plus x is 7, y minus x is 1, y minus 3x is negative 1. Now remember, the first step, you pick the 2 easiest equations and you solve them. You get a coordinate, substitute it into the third one and see if you get the same answer. If you do, great, they're concurrent. If you don't, they're not. Well, this one and this one are definitely the 2 easiest to solve, so they're the ones I'm going to solve, and this is the one I'm going to substitute into. So I've got y minus x equals 1, and I've got y minus 3x equals negative 1. Now I could solve these one of 3 ways. So I could set them equal to each other, I could substitute, or I can solve them via simultaneous equations. Now with the way I've written them, it's just easiest for me to solve them like a pair of simultaneous equations. But it wouldn't matter which way I do it, I should still get the same answer regardless. So to solve these 2, I've got to subtract them, because y take away y gives me nothing, and that's what I'm looking to eliminate. So I've got negative x and take away negative 3x, the minus minus gives me a plus, that gives me 2x because we've got negative x plus 3x. I've then got 1, take away negative 1, which is 1 plus 1, so I get 2. So 2x is equal to 2. From that, I know that x equals 1. What I then do is take this and substitute it back into one of the 2 equations I've used. Don't put it in the one we've not. If you put it in that one, you're assuming it works, not showing. I have to put it in either one of these 2 equations right here, get my answer for y, and then substitute both parts into here. I can't just assume one part works. So I could take x equals 1, I'll substitute it into here. So I get y minus 1 is 1, so I know then that y is equal to 2. I should get the same answer here. Y take away 3 is negative 1. What take away 3 is negative 1? 2. Great, so I know the coordinate there for the intersection of those 2 lines is 1, 2. Now I have to see if it's the same for the third one. If it is, great, they're concurrent. So let's substitute these values into here. I get 3 times 2 plus 1, and I want that to be equal to 7. 3 2s are 6, 6 plus 1 means I can write 7 equals 7, great. What that means is the point works for this line as well. What I then know is that all 3 lines are definitely concurrent. They all meet at that same point. So I can then write that as well, that they meet at the point 1, 2. So if I was to sketch them, I'd have 3 lines like that. This point here in the centre would be 1, 2, where all 3 of them intersect. So that's me proving that these 3 lines are concurrent, and that's how I do it. The second question was I had 4y plus 3x is 1, 3y minus 2x is 5, and 5y minus 10x equals negative 5, and it was the same idea. Show if they're concurrent or not. Again, same set of steps. Pick 2 of them to solve, find your coordinate of intersection for those 2 lines, and substitute into the third to then get an answer. Will it be concurrent? Will it not? That will be determined at that stage. What I'm going to do for this one, I'm going to pick this equation and this equation again, and this is going to be the check equation. So I've got 3y, take away 2x is 5, and I've got 5y, take away 10x is equal to negative 5. Again, you could solve them any of the 3 ways you want. Just with the way I've written it, I'm going to stick to simultaneous equations. I want to make the coefficients of one of these correct and the same. So what I'm going to do, if I was to do this one, I'd have to multiply both equations. If I was to do this one, actually I would only have to multiply the top, because if I times everything by 5, that will make it 10 and 10, so I can eliminate that easily. Whole top one multiplied by 5 gives me 15y minus 10x equals 25. Bottom one stays the same, 5y, take away 10x equals negative 5. I've then got to do something with the equations to get rid of bits. Well, I've got negative 10x and I've got a negative there. The signs are the same, so I subtract. Negative 10x, take away minus 10x. Negative 10x plus 10x is nothing. That vanishes, great. 15y take away 5y gives me 10y. And 25 take away negative 5, minus minus becomes a plus. 25 plus 5 gives me 30. 10y is 30. I know that y is equal to 3. Again, I could take it back and substitute it into any one of these two equations. Again, don't put it into the other equation we haven't used. We're proving, not assuming it's correct. Plug it into here to get what my x value is. I get 3 times 3, take away 2x is equal to 5. So 9 minus 2x is 5. 2x is equal to 4. X is equal to 2. 9 take away 4 is 5. Spot on. So I can then say my point of intersection for those two lines is 2, 3. Great. Now I have to see if the three of them are concurrent. To do that, I take this equation and substitute this in. If it works, great, they're concurrent. If it doesn't, tough, it's not concurrent. So let's try it. So I get 4 times 3 plus 3 times 2 equals 1. That's ultimately what I want. So I've got 12 plus 6, which gives me 18 equal to 1, but it doesn't, so it doesn't work. What I can then say is therefore they're not concurrent. All three lines do not meet at the same point. So if we were to sketch it, it would look something like that. All three of them meet at points, but they don't all meet at the same point. So they do cut, just not together. Proving a line's concurrent or not, those are the steps we have to take. We have to remember, pick two, make it the easiest if you can, solve them, get your point and substitute into the third. Don't make the mistake though of substituting at this stage. It's when you get the full coordinate, not when you get part of it.